The 12 microservices patterns that define modern architecture. The evolution from monolith to microservices. Why patterns matter. Microservices architecture has transformed from a trendy concept to an enterprise necessity, but with this transformation comes complexity that can overwhelm even experienced architects. These 12 patterns represent the distilled wisdom of countless production deployments, failed experiments, and hard-learned lessons. They're not just theoretical concepts, they're survival tools for navigating the distributed systems landscape. The Gateway Guardians, patterns 1 through 3. The API Gateway Pattern. The single point of truth. The API Gateway pattern serves as the architectural bouncer for your microservices ecosystem. Rather than exposing dozens of service endpoints to clients, the gateway provides a unified interface that handles routing, authentication, rate limiting, and request transformation. This pattern solves the fundamental problem of client complexity. Without it, mobile apps would need to maintain connections to multiple services, handle different authentication schemes, and manage varying API contracts. The gateway abstracts this complexity, presenting a clean, consistent interface while handling the messy reality of service coordination behind the scenes. The Saga pattern, distributed transaction salvation. The Saga pattern addresses one of microservices' most challenging problems, maintaining data consistency across service boundaries. Traditional database transactions don't work when data is distributed across multiple services, each with its own database. Sagas break complex business transactions into smaller, compensable steps. If a step fails halfway through a multi-service operation, the Saga can roll back by executing compensating transactions for completed steps. This pattern transforms the nightmare of distributed transactions into manageable, auditable workflows. The Event Sourcing Pattern, the immutable truth. Event sourcing revolutionizes how we think about data storage by treating events as the source of truth rather than current state snapshots. Instead of updating records in place, every change is recorded as an immutable event. Current state is derived by replaying these events. This pattern provides natural audit trails, enables time travel debugging, and makes complex business logic more transparent. When regulatory compliance demands complete transaction histories, event sourcing isn't just helpful, it's essential. The Reliability Resilience Patterns, patterns 4 through 6. CQRS, the Read-Write Separation Revolution. CQRS recognizes that reading and writing data have fundamentally different requirements. Write operations focus on business logic validation and consistency, while read operations prioritize performance and user experience. CQRS splits these concerns into separate models, allowing each to be optimized independently. Write models can be normalized for consistency, while read models can be denormalized for speed. This separation enables systems to scale reads and writes independently, crucial for high-traffic applications. The Strangler Fig Pattern, the Gradual Migration Strategy. The Strangler Fig pattern provides a humane approach to legacy system modernization. Named after the Strangler fig vine that gradually envelops and eventually replaces its host tree, this pattern allows organizations to migrate from monoliths to microservices incrementally. Rather than risky big bang rewrites, the Strangler fig approach intercepts requests to legacy functionality and gradually redirects them to new microservices. This pattern reduces migration risk, enables continuous delivery of business value, and provides fallback options when new services encounter issues. The Service Discovery Pattern, the Dynamic Directory. In dynamic microservices environments, where services can start, stop, or relocate at any time, the Service Discovery Pattern maintains a registry of available services and their network locations. Services register themselves on startup and deregister on shutdown, while clients query the registry to find healthy service instances. This pattern enables elastic scaling, graceful handling of service failures, and simplified deployment processes. Without service discovery, microservices deployments become brittle and difficult to manage at scale. The Stability Sentinels, patterns 7 through 9. The Circuit Breaker Pattern, fail fast, recover faster. The circuit breaker pattern protects services from cascading failures by monitoring downstream dependencies and opening the circuit when failures exceed acceptable thresholds. Like electrical circuit breakers, this pattern prevents damage by stopping the flow of requests to failing services. Circuit breakers implement 3 states: closed, normal operation; open, failures detected, requests blocked; and half open, testing if the downstream service has recovered. This pattern is essential for building resilient systems that can gracefully degrade rather than catastrophically fail. The bulkhead pattern, isolation for resilience. Inspired by ship design, the bulkhead pattern isolates different parts of a system to prevent failures from spreading. Just like bulkheads in ships contain flooding to specific compartments, this pattern separates resources and operations to limit blast radius during failures. Bulkheads can isolate different types of operations, user groups, or even individual customers. By ensuring that critical operations have dedicated resources, this pattern prevents system-wide outages caused by resource exhaustion or cascading failures. The database per service pattern, data autonomy. The database per service pattern ensures that each microservice owns its data completely, with no shared databases between services. This pattern enforces loose coupling, enables independent scaling and technology choices, and prevents the distributed monolith anti-pattern. While this pattern introduces complexity around data consistency and querying across services, it provides the foundation for true service independence. Teams can choose optimal data storage technologies for their specific use cases without being constrained by other services' requirements. The helper patterns, patterns 10 through 12. The sidecar pattern, the faithful companion. The sidecar pattern deploys helper functionality alongside main services, typically in separate containers within a pod. Sidecars handle cross-cutting concerns like logging, monitoring, security, and networking without polluting business logic. Service meshes heavily rely on sidecar proxies to provide features like traffic management, security policies, and observability. This pattern enables consistent infrastructure capabilities across all services while maintaining service independence. The retry pattern, persistence pays off. The retry pattern handles transient failures by automatically retrying failed operations with appropriate backoff strategies. Network hiccups, temporary resource exhaustion, and brief service unavailability are common in distributed systems, and intelligent retries can mask these issues from users. Effective retry patterns implement exponential backoff, jitter to prevent thundering herds, and circuit breaker integration to avoid retrying permanently failed services. The pattern requires careful tuning to balance user experience with system stability. The API composition pattern, efficient data aggregation. The API composition pattern addresses the challenge of efficiently retrieving data that spans multiple microservices. Rather than forcing clients to make multiple API calls and perform client-side joins, this pattern provides specialized composition services that aggregate data from multiple sources. API composition can be implemented at the gateway level through dedicated aggregation services or using GraphQL. The pattern reduces network overhead, simplifies client logic, and provides opportunities for caching and optimization. The pattern ecosystem, how they work together. These patterns don't operate in isolation. They form a cohesive ecosystem where each pattern addresses specific challenges while complementing others. API Gateway works with service discovery to route requests to healthy service instances. Circuit breaker and retry patterns collaborate to handle failures gracefully. CQRS and event sourcing often pair together for complex business domains. Saga patterns coordinate database per service implementations. Sidecar patterns can implement circuit breaker and retry logic. Implementation reality beyond the diagrams. While these patterns solve architectural challenges, implementing them successfully requires understanding their trade-offs. Complexity versus benefits. Each pattern adds operational complexity. Teams must evaluate whether the benefits justify the additional infrastructure and cognitive overhead. Technology maturity. Some patterns require mature tooling and deep expertise. Organizations should assess their technical capabilities before adopting complex patterns. Cultural readiness. Microservices patterns often require organizational changes around team structure, deployment processes, and operational responsibilities. The modern microservices landscape. These 12 patterns have evolved from experimental concepts to production-proven solutions. They represent the collective experience of the software industry grappling with distributed systems complexity. Modern platforms like Kubernetes, service meshes, and cloud-native technologies provide infrastructure support for these patterns, making them more accessible than ever before. However, patterns are tools, not solutions. The art of microservices architecture lies in knowing which patterns to apply, when to apply them, and how to adapt them to specific contexts. The path forward, pattern-driven architecture. Successful microservices adoption follows a pattern-driven approach. 1. Start with business requirements and identify which patterns address your specific challenges. 2. Implement patterns incrementally, learning from each deployment. 3. Measure pattern effectiveness through metrics and operational experience. 4. Evolve pattern implementations as requirements and technology mature. These 12 patterns provide a foundation for building resilient, scalable microservices architectures. They represent years of collective learning distilled into actionable architectural guidance. Master them, and you'll be well equipped to navigate the complexities of modern distributed systems. Remember, patterns are guides, not rules. The best architecture is one that solves your specific problems while remaining maintainable by your team.